Welcome to material session of Apulsa's Career Point. This is a video for the student of class 12 on unit 8. This is the first chapter of this unit, namely aldehydes and ketones, and this is the sixth video in this chapter, covering the topics preparation of aldehyde and ketone from alkyl cyanide by reduction with stannous chloride and HCl and from acid chloride. Last चारिटी भिडियो रे आमे प्रिपरेशन कथा पढ़ीचु. Preparation from alkyl cyanide मध्ये आमे how ketone is obtained from alkyl cyanide by reaction with Grignard reagent गत भिडियो रे पढ़ीथिलु. एबे देखियो से alkyl cyanide रो हमको aldehyde केमिति मिलिबो by Stephens reaction, and from acid chloride how aldehyde and ketones are obtained. From alkyl cyanide by reduction with tin in HCl or aldehyde by Stephens reduction. When alkyl cyanide undergoes reduction in the presence of stannous chloride and HCl, then the pi bond between carbon and nitrogen breaks and two hydrogen atoms are added to them, as a result of which we will get aldimine, and HCl is combined with it to give us aldimine hydrochloride, which an acidic hydrolysis gives us aldehyde and ammonium chloride. So in the statement what you have to write down, when alkyl cyanide undergoes reduction with anhydrous stannous chloride and HCl, then corresponding aldimine hydrochloride is formed, which an acidic hydrolysis gives corresponding aldehyde. This reduction is called Stephens reduction or simply Stephens reaction. Noted below. Ketones cannot be obtained by this method. The Stephens reduction method रे आमे ketone पाई परिबा नहीं. एबे देखिबा examples. Let us take C3 in place of R. Then alkyl cyanide जगह में methyl cyanide लू. When methyl cyanide undergoes reduction in the presence of stannous chloride and HCl, then similarly the pi bond breaks between carbon and nitrogen and two hydrogen atoms are added to them, as a result of which acetaldimine hydrochloride is formed, which an acidic hydrolysis gives us acetaldehyde or ethanol together with ammonium chloride. Now in the statement we have to write down, when methyl cyanide undergoes reduction with anhydrous stannous chloride and hydrochloric acid, then acetaldimine hydrochloride is formed, which an acidic hydrolysis gives acetaldehyde. This reaction is called Stephens reaction. Now let us go to how aldehyde and ketones are obtained from acid chloride. Preparation of aldehyde from acid chloride by reaction with Grignard reagent. एक कथा में लास्ट वीडियो मध्ये पढ़ीथिलु जे Grignard reagent को आमे दुईटा वे रे पाइथिलु. गोटे अल्काइल फॉर्मेट सहित रिएक्शन करी पाइथिलु, गोटे HCN सहित रिएक्शन करी पाइथिलु. एबे अल्काइल फॉर्मेट जगार आमे नै जिबा formyl chloride. Whenever formyl chloride reacts with the Grignard reagent, then an adduct is formed. Adduct केमिति formation होबो? The bond between carbon and oxygen in formyl chloride is polar. Due to more electronegativity, the oxygen atom acquires partially negative charge, while the carbon atom acquires partial positive charge. In case of Grignard reagent, alkyl group is negative and magnesium is positive. Thus an adduct is formed, which an molecular arrangement gives us aldehyde and magnesium chloride. In the statement we have to write down, when Grignard reagent adds with formyl chloride, then an adduct is formed, which an molecular arrangement gives corresponding aldehyde. Now let us come for example. Let us take C3 in place of R. So the formyl chloride methyl magnesium chloride से reaction करिवो. Similar way रे गोटे adduct ये दबो, additional product ये दबो, which an molecular arrangement gives us acetaldehyde and magnesium chloride. Thus in the statement we have to write down, when formyl chloride adds with methyl magnesium chloride, that is Grignard reagent, then an adduct is formed, which an molecular arrangement gives acetaldehyde. Which aldehyde is obtained? It depends upon the alkyl group of Grignard reagent. Let us come to know how aldehyde is prepared from acid chloride by Rosenmund's reduction. Rosenmund reduction ले आमे केमिति aldehyde पाइबे acid chloride पाखरु. When acid chloride undergoes reduction in the presence of palladium and barium sulfate, then corresponding aldehyde is formed. This reduction is called Rosenmund reduction. We know that whenever reduction is carried out, aldehyde is reduced to give alcohol. So in order to get aldehyde, this reaction must be carried out in the presence of some poisoning agent like a little amount of quinoline, xylene or sulfur to poison the reducing catalyst palladium and barium sulfate. Thus, we have to write down when acid chloride are reduced by hydrogen in the presence of palladium catalyst supported on barium sulfate, then aldehyde is formed. This reduction is called Rosenmund reduction. Ketones cannot be prepared by this method. Noted below, since aldehyde is further reduced to primary alcohol, a little quinoline, xylene or sulfur is added to poison the catalyst. Now let us come for example. Let us take C3 in place of R. Then the acetyl chloride undergoes reduction in the presence of palladium supported over barium sulfate gives us acetaldehyde. This reaction must be carried out in the presence of poisoning agent like a little amount of quinoline, xylene or sulfur. As a result of which acetaldehyde cannot undergo further reduction to give us ethyl alcohol. So in the statement we have to write down when acetyl chloride undergoes reduction in the presence of palladium catalyst supported over barium sulfate, then acetaldehyde is formed. This reduction is called Rosenmund's reduction. Now let us know how ketones are obtained from acid chloride. By reaction with Grignard agent. In case of aldehyde हमें formyl chloride नौतले, in case of ketone हमें acid chloride नबा. जब acid chloride को Grignard agent reaction करीबा alkyl magnesium halide सहित जब acid chloride alkyl magnesium chloride reaction कला कौन होगा? The bond between carbon and oxygen in case of acid chloride is a not purely covalent. It is polar covalent. It is polar in nature. Due to more electronegativity of oxygen, it acquires partial negative charge, while carbon acquires a partial positive charge. In case of Grignard agent, alkyl groups acquires a partial negative charge and magnesium acquires a partial positive charge. Thus, an adduct is formed in between acid chloride and alkyl magnesium chloride, which a molecular rearrangement gives us corresponding ketone and magnesium chloride. In the statement, we have to write down when Grignard's reagent adds with acid chloride, then an adduct or additional product is formed, which a molecular arrangement gives corresponding ketone. Let us come for example. Let us take C3 in place of R. Then when acetyl chloride or ethanol chloride reacts with methyl magnesium chloride, in the same way an adduct is formed, and which molecular arrangement gives us acetone or propanol. In the statement we have to write down when acetyl chloride adds with methyl magnesium chloride, that is Grignard's agent, then an adduct is formed, which a molecular arrangement gives acetone. From acid chloride, how ketone is obtained by reaction with dialkyl cadmium. तो acid chloride को हमें dialkyl cadmium से reaction करीबा in the presence of dry ether, then what happens? Now it will gives us ketone. The chlorine atom of acid chloride is substituted by the alkyl group of dialkyl cadmium and will get ketone together with cadmium chloride CdCl2. In the statement we have to write down when acid chloride reacts with dialkyl cadmium in the presence of dry ether, then corresponding ketone is formed together with cadmium chloride. This reaction is carried out only to obtain ketone from acid chloride, because by Rosenmund reaction ketones cannot be obtained. Let us come for an example. Whenever acetyl chloride reacts with dimethyl cadmium, R जगह हमें C3 नहीं चु, अड्डा जगह भी C3 नहीं चु, then it will give us acetone or propanol. जब acetyl chloride dimethyl cadmium से reaction करीबा dry ether presence रे, से हमको acetone बा propanol दबो. In the statement we have to write down when acetyl chloride reacts with dimethyl cadmium in the presence of dry ether, then acetone is formed together with cadmium chloride. Thanks for watching Gopal Sir's Career Point. Please like and share this video. Don't forget to subscribe my channel if you are watching it for the first time. Don't forget to hit the bell icon to get timely updates of my new video.